whenever you want to shoot outside, everyone tries to mow their lawn. You know what else can be kind of considered surprising? Water. And with the right circumstances, I could even take water that's flowing down and spread it straight up. How? All of these things are possible thanks to the study of flow of fluids, known as fluid dynamics. Because fluids in motion are dynamic, and there are many things going on in and around them all at once. So, in order to grasp the essential of fluid dynamics, let's just do some pretending, shall we? And much like kinetic friction with moving objects, viscosity tends to complicate things in moving fluids, which is why we're originally going to pretend that the fluids we're studying don't have any. Now, say you have some water, which exists under all hypothetical conditions in a pipe, moving along smoothly. This pipe narrows about halfway through. The one end is narrower than the other. This shape is going to affect some of the properties of the water's flow, and passes through the narrower side of the pipe compared to the wider side, but one thing won't change, is the mass of the water that's moving through any given area in the pipe over time. This is called the mass of flow rate, and it's always going to be the same everywhere in the pipe. That's just because as the water flows through the pipe, it pushes along the water in the rest of the pipe too. So, if one part of the pipe has, say, a kilogram of water moving through every second, the rest of the pipe has to have a kilogram of water moving through every second. This fact, the mass of flow rate at one point in the pipe will be equal to the mass of flow rate at any other point is called the equation of continuity. Let's say you are an engineer from a field of Barangay Inayagan, and you need to understand the mass flow rate of Mapil's water that is going through a certain point in your barangay, but you don't know the mass that is going through that part of the pipe at any given moment. All you know is the velocity and the area of the cross-section of the certain section of pipe. It's the same thing to say. The mass flow rate is the same for every point in the pipe, but instead of putting the relationship in terms of the mass and time, we're putting it in terms of area and velocity. And in your role as a water department engineer of Mapil, this is important for you to know, because it means that where the pipe is narrower, the fluid will have to flow faster in order to compensate. But here's the weird thing, a fluid that is flowing really fast actually has less pressure than it's flowing more slowly. Sure, it may feel like it's exerting more force than when it flows through a wider opening, but that's not what physicists mean when they talk about the pressure in the pipe. They're really talking about the pressure in the walls in the pipe. This means that the slower the fluid flows, the more pressure it puts on the pipe itself. This is known as the Bernoulli's principle. It states that a higher fluid velocity is through a pipe, the lower the pressure in the walls of the pipe, and vice versa.